So in the previous class, on the previous session, we discussed about the flow through capillary and the flow through the parallel surfaces, where we discussed about the discharge Q between the capillary as well as the maximum velocity of the flow of the oil in the capillary, as well as again the discharge and the maximum velocity of the flow when the flow takes place between two parallel surfaces. And also we have solved one problem in the previous session. We will continue with the numericals. We will take up the second problem now. So the second problem is an oil supply line 3 meter long having internal diameter 6.5 mm. So there is a line, oil supply line, there is a tube or pipe for which the length of the tube is 3 meter as well as the internal diameter is given as 6.5 mm. So I need to convert this into meters, because you will be dealing with the viscosity of the fluid, which will be given as Pascal second or centipoise Cp. So Pascal means 1 Newton per meter square. Okay, so an oil supply line 3 meter long having internal diameter 6.5 mm and delivering 6 into 10 power minus 5 meter cube per second of oil having a viscosity of 65 centipoise. Find the pressure loss in the supply line and the energy required in forcing the oil through the supply line against viscous friction. So this is the problem given. So in this problem, if you just try to collect the data, so length of the tube is given, L is equal to 3 meter, then the diameter of the tube is given 6.5 mm, you need to convert it to meters, 6.5 into 10 power minus 3 meters, then delivering 6 into 10 power minus 5 meter cube per second. So meter cube per second means this is discharge Q. Q is given of oil having viscosity of the oil also given as 65 centipoise. So 65 Cp, centipoise, you need to convert centipoise into Pascal second. So converting centipoise into Pascal second, you need to multiply this with 10 power minus 3. So 65 centipoise equal to 65 into 10 power minus 3 Pascal second. Okay, you need to take it in Pascal second. 65 into 10 power minus 3 you need to substitute. Then find the pressure loss. You need to find the pressure loss here. So pressure loss means P1 minus P2 on either side, the pressure on either side. So the difference between the pressure on either side gives you the pressure loss. So you need to calculate the pressure loss, means you need to calculate P1 minus P2 in the supply line and energy required in forcing the oil. So energy required is discharge into the pressure is the energy. So pressure you will be calculating first, then multiply that pressure into the given discharge, you will get the energy required to force the oil through the supply line against the viscous friction. So this is the problem given. Try to collect all the data, convert all the units. Then this is the formula which you have already derived in Hagen-Poiseuille law. So Q is equal to pi r to the power of 4 divided by 8 eta into P1 minus P2 divided by L. So it is the direct substitution. Q is given 6 into 10 power minus 5 and r square, r to the power of 4. Here diameter is given 6.5 divided by 2, 3.25 multiplied by 10 power minus 3 to convert millimeter to meters, whole to the power of 4 divided by 8 into eta is the viscosity, 65 centipoise is given. We need to convert centipoise to Pascal per second, Pascal second. So 65 into 10 power minus 3 Pascal second, 65 Cp, 65 into 10 power minus 3 Pascal second multiplied by P1 minus P2, that is what you need to calculate, divided by L, length 3 meter, substitute 3 meters. So from this equation calculate P1 minus P2, that is the pressure loss. So this is the pressure loss, and if you want to calculate the energy required, energy is equal to discharge into the pressure, and that is equal to discharge, it is already given, and the pressure you have just now calculated, multiplied discharge with the pressure, you will get the energy required. Okay, so this is how you need to solve this particular problem. Then we will move on to the next one, the third problem. Two reservoirs A and B shown in figure below are connected by a horizontal capillary tube, and the system is filled with a liquid having an absolute viscosity of 24 centipoise. The length of the capillary is 2 meter. The diameter of capillary is 0.635 mm. This is 0. Determine the difference between this pressure in reservoirs A and B if the maximum velocity of the flow at the center line of the capillary is equal to 0.123 meter per second. Also calculate the flow through the capillary. So this is the problem given. Here there is two reservoirs, this is reservoir A and this is reservoir B. Okay, this is one reservoir and this is another reservoir, and there is a tube in between. So this is a capillary tube which connects reservoir A and reservoir B. Therefore, the pressure at reservoir A, consider it as P1, and pressure at reservoir B, consider it as P2. So P1 and P2 will be the initial pressure and the final pressure for this capillary. This is the capillary which is in between reservoir A and reservoir B. Okay, that is the horizontal capillary tube. And the system is filled with liquid. So this system is filled with certain liquid, something like this. For that, the viscosity, absolute viscosity is given as 24 centipoise. Okay, so again this 24 centipoise you need to convert to Pascal second, that is multiply this with 10 power minus 3. Multiply this with 10 power minus 3, you will get Pascal second. 24 into 10 power minus 3 Pascal second. The length of the capillary is 2 meter. The length of the capillary tube in between reservoir A and B is 2 meter. This is 2 meter here. There is one more information given. The diameter of the capillary is 0.635 mm. So this is the diameter of the capillary, 0.635 mm. Convert this to meters. Determine the difference between the pressure in reservoir A and B. That is, you need to again determine P1 minus P2. The difference between the pressure P1 minus P2. A and B, if the maximum velocity of the flow at the center line of the capillary is equal to 0.127 meter per second. So here maximum velocity is given. In the previous problem, discharge was given, but in this problem maximum velocity is given to calculate the pressure loss. Okay, you can relate the discharge with the pressure loss, or you can relate maximum velocity with the pressure loss. Okay, both you have derived using Hagen-Poiseuille law. Also calculate the flow through the capillary. So also calculate the flow through capillary means you need to calculate the discharge also. So here first of all you need to calculate the pressure loss with the help of the maximum velocity. So we have the formula from the Hagen-Poiseuille law that maximum velocity is equal to Umax is equal to R square divided by 4 eta into P1 minus P2 by L. This is the formula you can extract from the derivation. So Umax is given here. Umax is nothing but 0.127 meter per second. R square diameter is given. The diameter being 0.635 mm. Multiply 10 power 3 minus 3 to convert millimeter to meter, divided by 2 to get the radius. Substitute here, and the viscosity it is given 24 cp. Multiply 10 power minus 3 to convert cp to Pascal second. Substitute here. Then L, length of the capillary also given 2 meter. Substitute directly as 2 meter. You have to substitute it in meters. So if you substitute for U, R, eta and L, you will be getting P1 minus P2. P1 minus P2 you will be getting as 0.2418 megapascal. So using the pressure loss you can able to calculate the discharge. Here using the discharge here you have calculated the pressure loss. In this problem, using the pressure loss obtained from the maximum velocity, you will be calculating the discharge. Again, copy the formula, substitute, calculate, get the answer. So this is how you need to solve the problem for the flow as well as the velocity or the energy required or the pressure loss in a flow through a capillary tube. So the fourth problem, the next problem, calculate the flow through slot 200 mm wide, 0.3 mm thick and 400 mm long, used to connect two reservoirs filled with an oil SAE 30 at 105 degrees Celsius. The pressure in two reservoirs being 2 megapascal and 0.5 megapascal respectively. Also calculate the energy required in forcing the oil through the slot against the friction. So this is the next problem. Carefully just check the cross section through which the flow has to take place. So here a slot of 200 wide and 0.3 meter thick, 200 mm wide and 0.3 meter thick slot is given. So by looking at the dimension, you can able to conclude that there is a flow between parallel plates. Okay, it is the width and the length is given, a rectangular section. So we need to conclude that it is not a capillary tube on which you need to work, it is on the flow between parallel plates. Okay, because width as well as thickness is given, then the length also given. Length, width and the thickness is given. Okay, so it is a flow between two parallel plates. So if you try to collect the data, B is given as 200 mm, the width and the thickness is given as 0.3 meters, 0.3 meter, then length is given as 400 mm. You need to take all other dimensions in meters because you will be substituting viscosity in meters. Viscosity you will be substituting in Pascal second. Pascal means 1 Newton per meter square. So since Pascal is in meter square, 1 Newton per meter square second, since viscosity is in meters, you need to convert these two units in meters. You need to take all other dimensions in meters. Okay, so convert 200 into meters, 200 into 10 power minus 3 meters, 400 into 10 power minus 3 meters. Then it is used to connect two reservoirs filled with oil of SAE 30 at 105 degree Celsius. So here the specification of the oil is given. The specification of the oil is SAE 30 at 105 degree Celsius. Just open your data handbook, tribology data handbook, get the viscosity from the data handbook. In the previous problem, viscosity was directly given with the problem, but here the viscosity is not given. Instead, the specification of the oil is given as SAE 30 at 105 degree Celsius. So in the page number 23.7 in your data handbook, page number 23.7, figure 23.2b, 23.2b, you can able to get the viscosity. It will be exactly equal to the stress concentration charts. Okay, there will be curves and there will be checks, boxes and curves. You need to select SAE 30 oil and temperature will be given in the x-axis. So match that temperature 105 with SAE 30 and take it to the left hand side. In the y-axis you will get the viscosity. That is how I need to get the viscosity from the chart. So the chart will be something like this. Okay. So in the x-axis you will be having the temperature. In the y-axis you will be having the absolute viscosity. Then there will be curves, something like this. These curves will be specifying SAE. SAE is 60, 70, 30, 50 like that. So these curves are SAE curves. Okay. Here temperature is given as 105 Celsius, 105 degrees Celsius. So go to temperature 105 degrees Celsius and climb up until you meet the curve being SAE 30. Okay, then go to the y-axis to get the absolute viscosity eta. This is how I need to get the absolute viscosity. It is exactly equal to the stress concentration chart. Okay, you have studied in design. So from the data handbook you can obtain viscosity as 6 into 10 power minus 3 Pascal second. Then the formula, you can substitute the formula from the derivation of flow through two parallel plates, that is Q discharge is equal to BHQ by 12 eta into P1 minus P2 divided by L. So substitute entire thing. So B is given here. You need to convert B into meters, 200 into 10 power minus 3 meters. Substitute here H 0.3 whole to the power of 3, L 400 into 10 power minus 3, eta 6 into 10 power minus 3 Pascal second. This is what I am stressing. Pascal means Newton per meter square. So since Pascal is Newton per meter square, viscosity will be in terms of meters. Therefore, need to convert these two into meters. P1 minus P2, it is given as the pressure in the two reservoir being 2 and 0.5. So this is P1 and this is P2. Okay. So this is P1 and this is P2. 2 minus 0.5 into 10 power 6 for mega. You can substitute here, and upon substitution and calculation you will get Q discharge is equal to 2.812 into 10 power 4 meter cube per second. Then again you need to calculate the energy required. So energy is discharge multiplied with the pressure loss. So discharge into the pressure loss, discharge you have just now calculated, pressure 2 minus 0.5 into 10 power 6, this 10 power 6 is for mega. Here there is mega Pascal. So 2 into 10 power 6 minus 0.5 into 10 power 6, 10 power 6 I taken common. So if you calculate, you will end up with energy is equal to 421.87 Newton meter per second. So this is how I need to calculate the discharge as well as the energy in the flow through horizontal surfaces. Then the next problem, the fifth problem, two tanks are filled with SAE 60 at 30 degree Celsius and are connected by a rectangular slot of 100 mm wide, 0.5 mm thick and 400 mm long. If the flow required is 20 liters per hour, determine the pressure required in terms of head of oil. Okay. So here you need to determine the pressure, that means P1 minus P2 you have to calculate. So here again the cross section is given as rectangular, width, length as well as thickness is given. So it is flow between two parallel plates. Again the specification of the oil is given, SAE 60 at 30 degree. Go to the temperature of 60, select SAE 60 here the curve, then go to the y-axis, get the absolute viscosity. So in the same figure and in the same page number you will get absolute viscosity is equal to 650 into 10 power minus 3 Pascal second. Then the dimension information are given, just convert all the dimensions into meters. Then here Q, the discharge is given in terms of 20 liters per hour. Liters per hour, we need to substitute in terms of meter cube per second. Okay, here liters is given, I need to convert liter to meter cube. So liter to meter cube is 10 power minus 3, liter to meter cube. Similarly hours to second, 60 into 60 divided by 60, hour to minute into 60, minute to second. So 60 into 60, hour to second. So if I substitute all those things, I will end up with Q is equal to 5.55 into 10 power minus 3 meter cube per second. To convert liters per hours to meter cube per second. Again, copy down the same formula. Discharge between two parallel plates, pH cube divided by 12 eta into P1 minus P2 divided by L. Substitute all the thing by converting all the unit into meters. Substitute all the thing, and if you try to calculate, here Q is given, P1 minus P2 is unknown. If you try to calculate P1 minus P2, that is the pressure loss, you will end up with this 1.385 into 10 power 6 Newton per meter square. Or you can take this 10 power 6 into Newton per meter square as megapascal. 10 power 6 is mega, Newton per meter square is pascal. If you want to write this in terms of megapascal, just write it as 1.385 megapascal. That's it. So the next problem number 6. Two rectangular plates 10 mm by 120 mm are separated by a distance of 0.5 mm and the clearance is filled with SAE 40 at 30 degree Celsius. Determine the force required to induce a relative velocity of 0.1 meter per second. So here you need to determine the force required to induce the velocity. Okay, so you need to calculate the force here. No pressure is involved, no discharge is involved. Okay, so here it is the flow between two parallel plates. So it is the case of the flow between two parallel plates, because there is rectangular plates is given. Then it is separated by the distance so and so and so and so is given. Clearance is filled with oil. For that, the specification of the oil is given. So if you try to collect the data, B is 10 millimeter, B, length 120 millimeter, so it is B into L, H 0.5 mm, it is separated by a distance of 0.5 mm, this is the thickness, the rectangular plate, the thickness. Then the oil specification is given, SAE 40 at 30 degrees Celsius. So for this particular oil, from the data handbook, page number 23.7, figure 23.2b, you can get absolute viscosity is equal to 260 into 10 power minus 3 Pascal second. Okay, this is the information we have. So with the given information, we need to calculate the force. So what is the type of force, what is the type of flow here? The type of flow is something like this, tangential. It will be a laminar flow. Okay, laminar means laminates to laminates. The flow takes place between layers. Okay, so it is nothing but a tangential flow. For the tangential flow, obviously there will be shear stress induced. Whenever a member is subjected to tangential force, obviously there will be shear force induced in the body. So shear force and the shear stress. The relation between shear force and the shear stress is nothing but shear force divided by the area, shear area. Okay. So here shear area is given, area we can able to calculate because the dimensions are given, area I can able to calculate. Force is what we need to calculate. So if you can calculate the shear stress tau, then you can able to calculate the force, because here the flow is layer wise. Okay, therefore there will be shear stress developed. So from the shear stress you need to calculate the shear force. So how you can calculate the shear stress? We know that all the fluids considered here will obey the Newton's law of viscous fluid. So according to the Newton's law, we know that tau is equal to viscosity into velocity by the height. Tau is equal to eta into u by h. So tau is not known. To calculate tau, eta you have already obtained from the data handbook, 260 into 10 power minus 3, substitute here. U is given as 0.1 meter per second. Okay, so to induce this amount of velocity, what is the force we need to apply? So if this amount of velocity is induced, what is the stress developed First we need to calculate the stress developed, then from the stress we need to calculate the force. So point 1 substitute for U, then H 0.5 into 10 power minus 3, 0.5 it is given in millimeters. To convert millimeters to meters, 10 power minus 3. So from this you can get the shear stress as 52 Newton per meter square. We know that shear stress is equal to shear force by area. So shear stress we have just now calculated as 52 is equal to shear force is the unknown divided by the area B into L 10 into 10 power minus 3 into 120 into 10 power minus 3. So this one 10 into 120, 10 into 120. Since it is given in millimeters, to convert millimeters to meters it is multiplied with 10 power minus 3. So this is the area, force by area. If you cross multiply area with the shear stress, you will get the force. So shear force is equal to 0.0624 Newton. So this amount of force is required to induce the velocity, relative velocity of 0.1 meter per second. So this is how I need to solve for the force. Okay. So this will end up the numericals on the flow between the capillary as well as flow between the parallel plates. In the next section we will take up numericals on the Petrov equation. Thank you.